Okay, so we're going to take a look at it's an idea of expanding and simplifying. So the very first step to this is trying to recognize that, and I should put, no, we have some kind of equation here. Each bracket, think of it as representing a term, okay? And really we have some term, we could call it A, multiplied by the other term B. Except that A and B aren't so simple. There's actually multiple terms within them that represent them. So we have to simplify them in a way. Now, when we look inside the brackets, I can't actually simplify anything. These are not like terms. So instead of doing that, we do something called expanding. We expand this to see if there'll be another way that we can approach simplification. So when we do that, because they would call this a binomial. You have two terms inside each sets of brackets. When you're multiplying, they use something called FOIL or rainbow method, but it's the idea of systematically multiplying the first term in the first bracket by both of the terms in the other bracket, and then multiplying the second term in the first bracket by both of the terms in the other bracket. And essentially, it's the idea of making sure that everything from one bracket is multiplied by everything in the other bracket, okay? I'll redraw it again because FOIL is a common way to write this, and I'll write it out here. So it stands for the first terms, outside terms, inside terms, and then the last terms. Okay, and what that means, and we'll rewrite it, x is -5, x plus 8. Ooh, kind of frozen me there. Okay, when we multiply the first terms, this is the first term in each set of brackets. So essentially, we multiply the two of those out. So we do x times x, that ends up being just x squared. We add the two exponents, and they're both to the power of 1. Then we do the outside terms. Well, the outside term would be the farthest to the left and the farthest to the right, okay? And if you notice at this point, the first term has been multiplied twice, and it's been multiplied by each of these, okay? X times 8 will give us positive 8x. 8 becomes a coefficient, x is still the variable. They're not like terms, so we can't simplify them anymore, so we just represent them as being multiplied by each other. And then we do the inside terms. So the term on the right on the first and the term on the left on the second bracket, which is -5 times x. So that actually gives us -5x. And then finally, the last terms in each sets of brackets. If you notice, I end up underlying every term twice, and that's how we know we've done it properly. -5 times 8 gives us a -40. Now we look for like terms. Like terms, we need bases. You get out of here. We need bases and powers that are the same. So x squared, I have no other variable to the power of 2. So x squared is its own term. There's nothing we can do with it. The other set, though, we have 8x and positive 8x and -5x. Both of those variables are to the power of 1, so those are actually like terms. So we can combine them. We just take a look at the two coefficients, which is an 8 and a -5. Well, that will give us actually positive 3. So the coefficient will change to positive 3, but we'll still have that variable x. And then finally, -40. This is just a constant term. I don't have any other constants, so this is it. This is the final term. And this is set up in what's called the standard form for a quadratic. So the general formula for something like this looks a little like this. Ax squared plus bx plus c. Okay, just to show you that there's a similar relationship. In the next one, it won't quite be like that because we have an additional variable. So this is more of a focus on the expanding and simplifying. This is more common because you're going to work with a lot of quadratics in the course. So this is a way of showing that when this is technically used to be known as factored form, we can switch it into our standard form by expanding and simplifying. Okay, let's take a look at the second one. We have to apply the exact same principles to the first term. Now the first term is actually, again, two terms together, but we're going to multiply them all in one shot. So what this really says is x times y times x. So I've expanded it a little just so we can deal with it, okay? And we'll do some simplification on the next line there. But we've done the first terms. We'll do the outside terms. Same idea again, x, y times -8x. So you can think of this like -8 times our y times our x times our y, okay? So we're thinking of multiplication when we go through it. We'll move over just a little. We'll do the inside terms. That's +5 and x. That one's a little simpler. That just becomes 5 and an x. And finally, our last terms, 5 and negative 8y. Well, our numeric values will multiply together. Negative 8 and 5 will give us negative 40, but I still have a y attached to it, so that y is going to stay there. We're going to take a look at those first two terms to see if we can simplify them at all. X and y, I can't simplify when multiplied, but x times x we can. Both of them are to the power of 1. So this actually becomes x squared y. It's a little trickier. It's multiple variables put together, okay? Which also brings us to our second term here. We have a negative 8. Can't simplify that. The x itself, there's only one of them, so I leave it. But there are two y's. And they're both to the power of 1, so we would add exponents when multiplying bases that are the same, and we get y to the power of 2. And then finally, these last two terms, there's nothing we can do to simplify them further. So we leave them as is. And then finally, our next step is to check for like terms. This has an x squared and a y. This is an x and a y squared. Those are actually not like terms. I can't do anything with them. This one has just an x. This one has just a y. That's actually it. I cannot simplify this any further. This would be as simple as this expression would get. A little different from our last one where we could do a bit of work after we expanded. Once we expanded in the second question, that's pretty much as far as we could simplify the question.